Hello, one and all. Bienvenue à tous. If you're tuning in live, thanks for making time for us in your busy day. If you're watching this on YouTube, thanks for stopping by. Whichever way you're watching, welcome to Post Media's fourth season of Driving into the Future. I'm David Booth, and I'm the senior writer for Driving.ca. Today, Driving into the Future will look at the hydrogen revival. Just a few years ago, hydrogen looked to have lost the energy race to batteries. Few were processing the most abundant element in the world. Fuel cell electric vehicles were being derided as fool cells, and seemingly everyone had given up on fueling internal combustion engines with hydrogen. Fast forward just a couple of years, and the future of hydrogen looks far brighter. Hydrogen production facilities are springing up around the globe. Numerous governments are subsidizing green hydrogen facilities, and the US government is considering a Hydrogen for Trucks Act, which would incentivize truck manufacturers and fleets to switch from diesel to hydrogen. A few enterprising companies, some right here in Canada, are even developing systems to retrofit internal combustion engines in big rigs to burn hydrogen. It's exciting times for those in the hydrogen industry, and to help us walk through the rapid progress, we're joined by perhaps the most interesting panel we've yet convened to discuss this new and emerging hydrogen economy. First up is Craig Scott, Director of Fuel Cell Systems at Toyota Motor North America. Then Jeff Grant, Vice President, Transportation Solutions for HTEC. Dr. Nasir Mahmood, Vice Chancellor, Senior Research Fellow at the Royal Melbourne Institute of Technology in Australia. And Jessica Verhagen, CEO of British Columbia's Hydra Energy. Welcome, ladies and gentlemen, and thanks so much for joining us today. Before we start the proceedings, let me also welcome all our viewers and inform them that we'll answer some of your questions later in this discussion. So, what an exciting time to be in the automotive industry. We're in the midst of a game-changing carbon reduction revolution, and we're finally looking at alternatives to battery-powered EVs. So how does the industry capitalize on this momentum, and what does a hydrogen revolution look like? Craig, I'm going to start with you. Why don't you walk us through fuel cells? What are they? How do they work? And do they really produce zero carbon emissions?
Thanks, David, for the opportunity to meet with you guys today and to have a chat. Happy to share what we're doing at Toyota. Fuel cells are, I like to think of them as sort of a next generation EV, or, they're the electric vehicle that makes its own electricity on demand. And as a result, it is a great zero emissions options for folks who, maybe an electric vehicle, a battery electric vehicle doesn't meet their needs in their daily driving cycle, or how they're living their life. And so a fuel cell is, just a very simple electrochemical device. We take hydrogen, we feed it through the fuel cell stack, and we make electricity, which powers the motor. And at the tailpipe, we get water. And as a result of that process, we can build a car like we do today, the Mirai, that goes up to 400 miles on a single fill, refuels hydrogen in 3 to 5 minutes, and is zero emissions at the tailpipe. So I think that hydrogen is a very important part of the energy transition, and it's good to see that after all these years, it's finally being recognized as such.
Quick follow-up on that. Are there, like there is for batteries, different chemistries for fuel cells, that have, stuff will work in the future, be more efficient? Or, are all fuel cells identical? And, do we have something to look forward to, both from the industry and Toyota, for greater efficiencies moving forward?
Sure, that's a great question. So fuel cells are all kind of generally the same, but they all sometimes have different properties, usually around what feedstock they use. So in our case at Toyota, we do what's called a PEM fuel cell, or proton exchange membrane fuel cell, which takes hydrogen directly and feeds it into the stack to produce electricity. But other manufacturers, or I shouldn't say manufacturers for autos, but other companies make fuel cells that are based on other kinds of feedstock. So there's things like molten carbonate fuel cells, where we have one of those actually in Long Beach at our facility, where we use natural gas, renewable natural gas, to make hydrogen and power. There's solid oxide fuel cells, which operate at a really high temperature. All kinds of fuel cells exist, and each of them have different properties and different conditions in which they operate. Some of them, continue to produce some low-level emissions, depending on the feedstock. Whereas in our case, we use low-temperature fuel cells, which are really very well-suited for vehicle applications and have no emissions.
Perfection. Thanks very much for the explanation, Craig. Jeff, I think many people are still out there, still confused by fuel cells, as in they don't understand what they really are. Aren't fuel cell electric vehicles and battery-powered electric vehicles just kissing cousins? Both are, I think, powered by electric motors. Both have inverters, don't they? So what's the difference, and why would anybody, or any industry for that matter, choose fuel cells over batteries?
Sure. Thanks, David, for the opportunity today. Yeah, I mean, you are correct. A fuel cell electric vehicle is an electric vehicle, absolutely, and there is a lot of commonality on the drivetrain. And I think Craig described some of that. Essentially, you're generating the electricity on board instead of storing it in a battery. So yeah, there's definitely a lot of sort of connection between the battery electric and the fuel cell vehicle. I think the big difference, though, with hydrogen is the energy density. So you can just store a lot more energy in terms of kilowatt hours in the tank of that Toyota Mirai, which I drive, by the way, Craig. You can just put a lot more energy in there, and so you're able to extend the range. So batteries have some advantages. Battery electric vehicles provide you better efficiencies typically, but fuel cells and fuel cell electric vehicles, because of that energy density, give you some advantages in terms of performance and range. And that's why we're seeing a mix of both technologies. I'm in Anaheim right now at a conference, and it's focused on advanced clean trucking, and we're seeing a lot of both. We're seeing a lot of battery electric technology and a lot of fuel cell technology, and companies like Craig's are providing both and working on both sides. Yeah.
Just to try to simplify it even further for some of the people listening that might not be familiar with the technology, would it be fair to say they're both very similar? They just get their energy from different sources. It's almost like the hydrogen fuel cell stack is a different kind of battery than the ones in a battery electric vehicle, or is that too simplistic?
I mean, you could probably get away with that. Yeah, there is a lot of commonality, and I think that's a great advantage that these vehicle OEMs, be it buses, trucks, or sedans, can use a lot of the same components. It's just picking the right tool for the job, essentially.
Thanks very much, Jessica. Not all hydrogen-powered vehicles have to be fuel cells, though, do they? Why don't you walk us through Hydra's system for converting diesel engines to be hydrogen powered? Is the process difficult? Is it expensive? And is it a bi-fuel system, as in, can the engine still run on diesel when there's no supply of hydrogen readily available?
David, thank you so much for having me here. I'll start with your last question first. So yeah, you can absolutely run the truck in diesel mode only. It'll seamlessly switch over when hydrogen runs out at about 1,000 kilometers. Of course, it varies a little bit on drive cycle. This alleviates the range anxiety that can often be a barrier to adopting new technology. You'll see in most of my discussion on this show will be about how we're trying to remove as many barriers as possible so we can get hydrogen into the heavy-duty trucking industry. For example, because it's still an internal combustion engine that we're using, it's just the same operation that drivers are already used to, their mechanics are already used to. As far as the cost to fleets go, and that's another area where there can be some barriers, with some of the alternatives being quite high cost and fleets having typically low profit margins. So we actually do the retrofits for free in exchange for a 5-year fuel contract. The fleet buys hydrogen from Hydra or from one of our licensees, and the cost of that hydrogen fuel is about on parity with diesel. Plus, they get a small efficiency gain. We're achieving about 2 to 5% by burning both fuels together. And with hydrogen burning cleaner, the maintenance costs typically go down. Like, for example, there's less cleaning and replacement of the diesel particulate filter. So There's nothing up front for costs, and there should be some operational cost savings. The conversion takes about 2 days to complete. It's platform agnostic. We've done Freightliners, Peterbilts, Volvo, MAN trucks. Part of that is because we've integrated machine learning, which we can go through a little bit later, so it can predictively analyze and come up with a hydrogen injection map. But the basics of the conversion are that we have some hydrogen tanks that we put on the back of the cab. They're holding the hydrogen at about 350 bar, and there's 40 kilograms of hydrogen on board. There's some gas handling components that's bringing that to the engine, and then there's an injection manifold for hydrogen that's installed in line with the air intake. It blends hydrogen and air before it goes into the engine block. And then there's our own engine control unit, which is installed behind the truck dashboard, and it controls hydrogen flow. So at the moment, we can displace up to 40% of the diesel with hydrogen, depending on the drive cycle of the truck.
That's so cool. And it's all retrofitted on top of the machine. It doesn't actually modify the truck. So, I mean, you could take it off, in fact, and nobody know the difference, right?
Mm-hmm. Yeah.
That's fantastic. Thanks so much, Jessica. That really does sound ingenious. Dr. Mahmoud, I've got to say I was incredibly excited to read about RMIT's breakthrough in being able to produce hydrogen from salt water. How do you manage to use salt water when every other process I've ever heard of requires fresh water for electrolysis? And how do you do it without creating more pollution and noxious gases? Can you just walk us through the basics of your breakthrough, please?
Thank you so much, David, for having me here. And it's really exciting to utilize the seawater rather than the fresh water. In fact, I was also fond of using fresh water initially. Like I was working on this hydrogen production from last 10 years, and my first 7 years are completely focused on utilizing the fresh water. But then as now the demand of hydrogen is increasing, and we know that it's going to be a next game changer, not only for the automobile technology, for many other industries and many other applications. And the demand it will increase rapidly in the coming years. And for the current predictions, it is estimated that the water required to meet the hydrogen demands is equal to feeding a country with a population of 62 million people. So just imagine, like if we are just stealing a water from 62 million people, so that will be a somehow threat to the survival of life. So we need to find alternative. So that is the seawater, right? That's an infinite source of water. And other prediction is that with the export demand of hydrogen, roughly only in Europe, 42% hydrogen will be around the ports. So then the best thing is to utilize is the seawater. The third reason behind this is, the hydrogen, we want to make it a green and clean. So that can only be possible when we will utilizing the renewable energy sources. So if we just think about the seashores that have the plenty of sun, they have the wind, and they have the tidal energy. So all form of and renewable energy sources are available there. So that becomes the best suitable places to produce the hydrogen as well. Why we just need to transfer the energy from there to somewhere else and then utilize the fresh water to split it. So that motivate us to find a way that we can utilize that seawater directly. But of course, as you mentioned, that when we use the salt water directly, in the traditional process, we will be producing some sort of toxic gases like a chlorine. At the moment, chlorine is considered as a valuable white byproduct because it is utilized by many industries. But the consumption of is up to 62 million tons per year. What we will be producing to meet the hydrogen demands, that will be more than 400 million tons. What we will do with the rest of that will be going into the environment. So we will be creating another issue to resolve by our next generations. So this is the reason that why we focus on to producing a hydrogen from seawater without producing any kind of toxic gases or any kind of other toxic emissions into the environment. Now let's move to your next topic, how we able to do it. So we try to understand the chemistry behind it, what happens, what thermodynamically is favorable, what is not favorable. Then we try to modify the catalyst that we utilize to split the seawater without producing the chlorines. So now we have developed that catalyst, and that catalyst is not only inhibiting the chlorine production, they are improving the efficiencies for the hydrogen and oxygen production. They are making sure that we are getting clean energy at the very less energy consumptions, so making the overall process very sustainable.
Thank you very much, Doctor. I've got to say, it sounds like exactly the breakthrough that the world needs to create a large supply of clean green hydrogen. Craig, Toyota is the leading proponent of hydrogen amongst automakers. You have fuel cell trucks operating at the Port of Los Angeles, Mirai sedans in California and British Columbia, and even a hydrogen-fueled turbocharged Corolla racing in Japan, I think. What I'm not seeing as clearly, however, is a plan with what you're doing with all this various different research. For hybrids, for instance, Toyota has a definitive plan ahead of it. Ditto recently for the recent updates to your battery-powered electric vehicle plan. So is there something similar, an overarching plan for hydrogen from Toyota? What do we have to look forward to?
Great question. Thanks again, David. I guess I would start by saying, these aren't research projects as you described them, right? We've been selling the Mirai in Japan and the U.S. and in Europe since late 2014. So we're getting close to a decade now of selling the light duty vehicle, the Mirai. And of course, always looking to expand that to new markets and open up opportunities for selling more fuel cell vehicles. And the truck program, which you mentioned. So just yesterday, here at the ACT Expo in Long Beach, we had a joint announcement with our partner PACCAR that we are going to start providing powertrains to them, fuel cell powertrains, for their heavy-duty truck applications. So now the Kenworth brand will be selling trucks, T680 trucks that are powered by Toyota fuel cells. So really kind of moving very deliberately into the space of expanding the opportunity for fuel cells and also the opportunity for hydrogen in general. And you may have seen some other announcements recently where we have deployed stationary fuel cells. And the most recent case was to the National Renewable Energy Lab in Golden, Colorado, which is a US DOE lab with a 1 megawatt fuel cell, which is all being powered entirely by our stacks. So the strategy is really to move and advance hydrogen as fast as possible. I think that for a long time, I've been doing this for 23 years at Toyota. For a long time, it's been Toyota kind of pushing really hard. But as you sort of alluded to earlier, things are changing, and now we have the federal government, as well as a lot more states beyond just California, that are moving very intently in the direction of expanding opportunities for hydrogen. And I think it's a good chance for all of us, but especially for Toyota to play in these spaces.
Would it be fair to say then that in the fuel cell arena, at least with mobility, that you're going to be a supplier to existing trucking firms, if that's where you go, but you'll build your own fuel cell cars? And when it comes to, if you ever do anything with the hydrogen fueled internal combustion engine, you'll also build it yourself, correct?
Yeah, it's a good question. I mean, it's a little hard to sort of predict the future, obviously, right? But I mean, I think where we sit today is, we're comfortable being a car manufacturer. That's what we do really well and we do best, and we're comfortable around. We're not a truck manufacturer. We don't make heavy duty trucks. So I think providing the powertrain for those folks is a reasonable place for Toyota to sit right now. In the future, of course, anything is possible, but we'll have to wait and see.
Thanks very much. Jeff, the biggest problem slowing down the proliferation of hydrogen-powered vehicles is a comprehensive refueling network. I believe your company, H-Tech, is the largest hydrogen refueler in Canada, but the industry still remains in its infancy and is still the roadblock to widespread hydrogen-fueled mobility. We need convenient refueling. Why don't you walk us through where we are, where we need to get to, and how we'll get there?
All right, happy to do that. So this is, of course, the chicken and the egg question that we've been, or the poultry question we've been talking about for a while. So first, a little bit about H-Tech. We work across the hydrogen value chain, from production, distribution, dispensing, and even on some end use heavy duty applications. We're involved there as well. So work right across that value chain. You know, to answer your first question, where are we? If you look at some of the more progressive jurisdictions in Germany, Japan, California, there are, for example, 57 stations. So we have these burgeoning networks. In British Columbia, we have five HTEC stations. There's a sixth station coming online in the next month or so. And then we have a fairly robust pipeline of additional stations that are all coming in. So, so that's sort of where we are currently. In Canada, the sort of the cluster of activity is focused in British Columbia, and that's where you'll see the Toyota Mirai and the Hyundai Nexo vehicles that are deployed here. In terms of where we need to get to, what we need to do is we need to move from sort of these limited deployments into more scaled operations. So to do that, the strategy that governments seem to be taking, and well, I'd say government and industry are developing what we call hydrogen hubs. And hydrogen hubs are in strategic regions, and they're focused on matching both the supply and demand equally. So we can scale up and we can get to the volumes that we need to drive the costs down for the equipment, for the fuel itself, and even for the operations. So in these hubs, what we're starting to see is hydrogen production that is being used for vehicles and being fed into these vehicle networks, but also that same hydrogen can be used for industrial applications. It can be blended with natural gas through decarbonized heating. It can be used for things like aerospace and marine applications. So, you know, that seems to be the best way to get where we need to get to that scale, is to aggregate our demand in specific regions and start there. And then eventually what happens is you start connecting these hydrogen hubs through corridors. And so if we've got one in British Columbia around, you know, a certain number of regions, eventually we can connect in with Alberta, who are doing their own hydrogen hub work. And then eventually that's going to connect into Winnipeg and you know, onto the 401 corridor. So that's if you look at the NRCan national strategy, that seems to be the way things are moving. And I think even if you look in the US and what the Department of Energy is doing, they're following that same pathway. So sorry for the maybe the long-winded explanation, but certainly hydrogen hubs, that seems to be the key that we're moving towards.
Any timeline, I mean, even in blue sky, for when, for instance, a big rig could leave Vancouver and get all the way to, say, Toronto or Montreal on nothing but hydrogen? I mean, is there anything like a goal, a dream, anything like that?
Well, there's a lot of activity and there's funding and there's stakeholder work and engineering that's going into that right now. You know, to try and peg a timeline to connect the entire Canadian market, I think that's going to come second. As I mentioned, I think you're going to get the hub development first, and then these corridors will develop second. I'd hope to see that by the end of the decade.
Okay.
Right.
Okay. That's good.
But in the meantime, we're going to have very robust, active hubs in British Columbia and Quebec, in the Edmonton region around Calgary and other places. So, you know, that's ongoing now.
Alberta will be greener than Ontario. That's a big statement. Okay, thanks very much, Jessica. So your company converts diesel engines to run on at least partially on hydrogen. What is the effect of this injection? Is carbon dioxide reduced? By how much? I think you've done some studies on that recently.
Yeah, good question, David. And I think it's really important that we quantify these claims, because there's lots of different, as you mentioned, the hydrogen industry has been picking up a lot, and there's a lot of different claims right now. So we actually published a paper in SAE, it's the Association of Engineers Internationally, that proves that the reductions in our CO2 emissions are directly related to displacing diesel with hydrogen. The data was also not just collected in a lab. it was on trucks that are operating on, you know, the normal day-to-day business between 2020 and 2022. So I think what's valuable about this is not only demonstrating the average CO2 reductions that we were getting in that older time period of 20 to 25% compared to the base diesel case, it's showing that that's the same as our average diesel displacement, meaning we reduce diesel by 25% and you get an equivalent amount of CO2 emission reductions. So that's really exciting for us to be able to prove in a peer-reviewed paper. And then especially because we're not talking about that lab environment, these are actually real commercial trucks on real routes with real commercial drivers. And we're still getting those positive results. Because the data is an average over a few years in the past, it's not really showing our continual improvement in that average value and also the top end. We're currently seeing up to 40% carbon emission reductions. And, you know, it's a continually improving number. I think when I started at Hydra back in 2019, it was up to, you know, low to mid 20s, and now we're up to 40%. So we're really excited to be able to contribute a solution that can do something meaningful for the trucking industry, which doesn't have a lot of cost-effective options.
So it's basically put 40% hydrogen in, you cut 40% CO2. That's fantastic. Follow-up now. What about nitrogen oxides? As the Dieselgate scandal continuously reminds us, because in fact, one of the Volkswagen people is pleading guilty still to part of that Volkswagen thing just this week. It's the scandal that never goes away. Anyways, as it reminds us, nitrogen oxides is a problem for diesel engines. Can the hydrogen that you inject solve those emissions as well?
Yeah, it's an interesting question. In that same paper that I was mentioning to do with CO2 emission reductions, our engineers also proved in those real world conditions that our co-combustion system, in the best case scenario, is reducing NOx, and in the worst case scenario, it's at least on par with existing diesel engines. We saw reductions of up to 20% of NOx, engine out NOx, so that's before the after treatment catalyst. As hydrogen burns at higher temperatures, it was actually assumed that there would be an increase, and that wasn't necessarily the case. So we are continuing to study the reasons why that's not the case. And we have some dyno tests that are upcoming with our academic partners, University of British Columbia and Simon Fraser University, on this project. But right now there's 3 factors that we're seeing as potential contributors. The first one is that our hydrogen injection system is in the lean combustion range, so the fuel to air ratio is lower. The second one is the hydrogen displaces some oxygen, which of course forms NOx. And then our third theory is that hydrogen combustion forms more water, which can absorb heat that's released during the combustion process.
That's really cool. I mean, that's a twofer in the emissions reductions arena. Very well done. And Dr. Mahmoud, you gave us an idea of why we want hydrogen from seawater. Can you tell us a little bit more of how you do it? What's the secret? The secret sauce? Is it a catalyst? Is it some other mechanism? Can you give us a little bit of an idea of how you do this?
Thank you so much. Good questions. So as I was just mentioning previously, so the main thing that make the seawater directly be useful in the electrolyzer is the catalyst, because normally seawater is a corrosive, so that destroy the catalyst. And also there is a lot of salt there, so that produce a chlorine, and that chlorine is a problematic, as I mentioned. It basically start corrosion and destroy the catalyst surface. So we have to overcome this kind of a chemistry. So we modify our catalyst in such a way that they inhibit all those kind of side reactions and make our catalyst more stable, so they can continuously keep operating for several hundreds of hours. And that's what we did, and we found that the catalyst the change in the chemistry of the catalyst make them really, really stable. There is a no impact of the chlorine on them. There is a no impact of other impurities in the seawater, because we supply directly seawater. So there is a no simulations, and there is a nothing, no makeovers of the water. It's a pure seawater that we directly, natural seawater we utilize, and that gives us the confidence that by changing these kind of chemistries, this can be achieved, that seawater becomes a source of a hydrogen. So there is a no threat to the survival of life, and the hydrogen can be more socially acceptable.
And so the catalyst that is the secret sauce here, it's also long lasting, so that this is a scalable and viable long-term solution, correct?
Yes, definitely, because what we develop, we keep in mind these things. They should be a cost effective, they should be durable, and they can keep going on for a longer operations, and they can be produced at industrial scales.
Thanks very much. Craig, being the head of a fuel cell division of the largest automaker in the world, one hopes that you have the attention of lawmakers everywhere, especially in North America. So my question to you, Craig, is how do we speed up this conversion to hydrogen as mobility? Do you see support? Do you see the support coming from government to make a breakout similar to EVs? I know the American government has passed something, the Hydrogen for Trucks Act. Will it work as efficiently as the Inflation Reduction Act has for the EVs? What do you need from government, and are we getting it?
Yeah, thanks, David. I'm not a policy guy, but I'll tell you that for doing it as long as I have, I do notice that when the policies are aligned towards supporting new technology and like hydrogen, that things tend to move a little bit smoother and a little bit faster. So if we kind of look back in time and think about California, right? So the policies that were put in place many, many years ago to support the development of infrastructure have certainly resulted in a lot of stations being built here. In the policies that were aligned around consumers to incentivize them to purchase cleaner vehicles like the Mirai certainly help move the needle and get the market activated, right? So I do think that that's an important process, or important part of the process in the transition towards decarbonization. And as you mentioned, at the federal government level here in the U.S., really very unprecedented in the last at least certainly in the time I've been working on this, unprecedented that there has been a movement towards funding hydrogen in a way that we see today. So, $9 billion is allocated towards the hubs. That money is, sort of being sorted out right now with respect to who's going to get it and where it's going to go. But, I think we're expecting to see 4, maybe 5 hubs as a result of all this, which will then really open the door for hydrogen a lot wider than it is today. So, today in California, we have a great playing field, and I would say that the programs that folks are taking advantage of have really sort of helped contribute to announcements like what we made yesterday with PACCAR with respect to providing heavy duty trucks or powertrains for heavy duty trucks. That opens those doors, and I would expect that the federal money will do the same. But for other locations that may have taken a little bit longer to come online for hydrogen. So. Absolutely, I think unquestionably very important to making the transition.
Thanks very much. Same sort of question for you, Jeff, but more specifically for Canada. And I think you helped write some of the policy for Canada. So what is the Canadian government doing to incentivize the production of hydrogen and, of course, hydrogen refueling stations? What are Canada's strengths and weaknesses in this regard, and what do we have to look forward to in the near future?
Sure. Thanks, David. Just to start with, we do have some good support from both the federal and provincial governments, and specific provinces. Certainly, as I mentioned, BC and Quebec are probably a little ahead of some of the other regions. Alberta as well. In the Canadian market, with government, we have an investment tax credit for the production of hydrogen. There was a $2 billion Clean Fuels Fund that was developed through NRCan to set up production. There's the Canadian Infrastructure Bank that's supportive of both the production, distribution, and fueling stations as well. That's very active. So in terms of strengths, I think Canada is doing very well in the production, distribution, and infrastructure, and that's the area we work in primarily. But like Canada in a lot of other areas, we tend to do very well in sort of the primary piece, but not right through the value chain. I'd say the sort of the weakness in terms of government support is probably on the vehicle side, and I'm speaking more to heavy duty vehicles than to the sedans and the light duty market. With heavy duty vehicles, there are pilot programs that the federal government has supported, and that's been really good and really helpful. There are subsidies available to pay down the delta or the incremental cost of fuel cell electric trucks, but that's more in a commercial time frame. The time frame right now where there's a large premium, it's very difficult for fleet operators to sort of fill in that gap, and the subsidies that are available through Transport Canada are not quite big enough to fill that. So you don't have, especially in the trucking sector, a lot of massive billion-dollar companies. You have a few, but it's mostly made up of smaller owner operators, and as I think Jessica was talking, they're very conscious about their costs and their bottom line. So I think on the vehicle side, that's probably where the Canadian government could take a good look and see how they can help the fleet operators deploy this equipment.
Thanks very much. A quick follow-up. I mean, you may have sort of answered this. The American government is just throwing so much money at everything green. The IRA, batteries, and electric vehicles. There's a new Hydrogen for Trucks Act. Even the Inflation Reduction Act does promote hydrogen as well. I mean, it forced Canada to spend $13 billion on getting a Volkswagen plant here in Canada. Do you see the monies being bandied about down there having an effect up here in Canada? Well, will our hands be forced? Will the governments be forced to work with the hydrogen community as they have the battery electric community?
Yeah, I think it'd be fair to say that the production tax credit and under the Inflation Reduction Act got the attention of the Canadian government. Absolutely. So there was an investment tax credit that was announced as part of the last budget. So that's good. I think, following up on, excuse me, the last question, yeah, you're asking about the Hydrogen for Trucks Act. I'm hopeful that act is going to stimulate some discussion and some activity, maybe within Transport Canada, to take a good look at that and see, how can we compete and make sure that that the truck deployments in the Canadian market match what we're seeing in these different hubs that are going to be developing in the U.S. So I think it will have a positive impact for sure.
Thanks very much. Good news from the government, perhaps, coming. Jessica, so far we've talked about your conversion of diesel 18-wheelers to hydrogen. But is the process only limited to diesels? Can it work for gas engines? Have you ever converted cars to hydrogen? And if so, how did it work? Was it any more complicated or expensive than your current diesel conversions?
Actually, in the early days of Hydra, one idea was to convert taxi fleets to run on hydrogen. The team successfully converted a gasoline Chrysler 300, and it did work quite well. On a technical level, it wasn't more complicated than our current system, but unit by unit, there was less profit margin than going with heavy-duty vehicles. The car only used a couple of kilograms of hydrogen per fill, so it just didn't work well with our business model, which is hydrogen as a service, and we're really aiming to deliver the hydrogen fuel through a fuel station, whether it's ours or through partners with others. So I think if one of your viewers wants to take this one on, and we'd be really happy to see that take off in the passenger market, maybe under a different business model where you're just selling the kit. So we've talked about before, David, like the NOS kits. Maybe you have something that's more focused on a hydrogen retrofit and selling a kit that way. But for us, we made a business choice more to focus on the heavy duty market. We also saw less competition in the heavy duty market, the passenger side. Of course, with Craig on the line here, they have Mirage and a bunch of really great options to go with. Whereas in Class 8 vehicles, there wasn't much that could produce the same performance, torque wise, or reduce range anxiety meaningfully. In Canada, it's, an interesting stat that I like to pull out is that while heavy duty trucks account for 1.37% of all vehicles on the road, they actually contribute over 30% of all transportation related emissions. So, we looked at, where can we make the most impact? And what's the best business case? And that shifted us from taxi fleets over into heavy duty trucks.
Got it. The business case makes perfect sense. Last question. As far as the cut in CO2 emissions was similar to what it would have been in your diesel conversions as well?
Yeah, it was earlier days, so it was a little bit less. If we tried to do it on a car now, I'm sure we would achieve similar results to what we're getting on heavy duty trucks.
Thank you. Well, guys, those are my specific questions for you, but my readers have a bunch more, and I've got to say, I think they're tougher than mine. For instance, Paul, a retired scientist, asked, would atomic energy be the best sustainable way to produce hydrogen? Nasir, you're in the business of figuring out how much energy is required. Why don't you tell us how much energy required to electrolyze water, and is nuclear one of the options as well as renewable?
Thank you. Yes. At the moment, I think the bigger cost factor is the energy utilized by the electrolyzer to produce the hydrogen. That's why the hydrogen is a bit costly and becoming more like a luxury product rather than it can be utilized by a common person. So the first thing that everyone is saying, we need to reduce the cost of the hydrogen. That's what we are doing by producing the cost-effective catalyst that can reduce that energy consumptions. So roughly at this, I think is around 50 kilowatt is required around to produce the hydrogens, but that is like a very high. So we need to bring the numbers under 40, and so that can make it a very cost-effective hydrogen. And the question that is the nuclear energy can be utilized? So it's a very simple process. So once we split the water, that's electrocatalytic, so means electricity utilized. So of course the nuclear energy produce electricity. That is simply we can utilize that one for the hydrogen production. But there is few other ways where the nuclear energy can also be utilized to produce the hydrogen. That's the high temperature thermochemical splitting of water directly into hydrogen and oxygen. So that definitely that will be one option to utilize the nuclear powers, but both have their own benefits, either using renewables and the nuclear powers, because when we use renewable energy sources, then hydrogen not only becomes like as a hydrogen product to be utilized in other things, it also becomes as a energy storage backup. So we can store the electricity into molecular form, and then we can utilize wherever it is required. In fact, it becomes a dual benefit. It can be utilized back as electricity, and it can also be utilized as a molecular form into different other industries.
Excellent. You mentioned cost, and that's going to be very, very, very important moving forward. Current pricing for a kilogram of clean hydrogen runs somewhere between $5 or $6 American, at least here in North America. Does your seawater process reduce that cost? How much? What is your goal? And how does that compare to, current energy sources?
Yes, our aim is to bring the hydrogen cost around $1 to $1.5 per kg. And that can only be done once we did make the process efficient. So there's a two kind of cost involved. That is the, of course, the capital that we put, and then the operational cost. In the operational cost is the one of the cost comes from the energy. That's what I say that like Arena, they set the targets to reduce the energy consumption by 15% by 2050. So we have already produced our second generations of catalyst and third generation of catalyst that we will also be reporting very soon, which make the process much more efficient than the target set by Arena. So we are aiming that we can reduce by that energy consumption by 20%. That will definitely bring the cost to 1 and 1.5 dollar per kg. And the second thing is that the catalyst that we are producing, they are 100,000 times cheaper than the commercially utilized catalyst. Like we are just only making the catalyst which is 60 to 120 dollar per kg, as compared to if we talk about that noble metal based catalyst which cost around 100,000 to 150,000. That's very expensive. So that overall makes the process very cost effective and help to reduce the cost of hydrogen production.
Wow, cheap and green. Well done.
Yes,
Well
that's our
done,
aim.
Dr. Mahmood. Well done. Jay asks, and this question we've sort of danced around, but they being a reader and not a journalist, asked it much more directly than I would, I guess. Basically, Jay asks, given the slow but increasing investment in the national EV charging network, how difficult will it be to build a nationwide hydrogen refilling network? Jessica, you're a hydrogen supplier. And you're trying to build stations, I believe, between British Columbia and Alberta. How difficult is it going to get us to make it nationwide?
Yeah, definitely a direct question, Jay. And I think Jeff touched on building corridors and connecting those across the nation, over the remainder of this decade. But certainly there's a lot of lessons to be learned from the EV infrastructure rollout, not only in Canada, but also abroad. I know in some of the European hydrogen strategies, they specifically cite how they're shaping current policy for ramping up hydrogen refueling stations based on some of those lessons learned. In Canada, Hydra's been focused on a go-to-market strategy where we look at trucks that return to base. We don't want to wait for the perfect network, call that impatience, or, we just think it's important to be practical and get technology out as soon as we can that starts addressing our emissions and bring some more fuel diversification into the market. So in Canada, about 23% of trucks are returned to base. So that means they're going out and coming back again. We focus on those trucks that do so within our hydrogen range, which is about 1,000 kilometers. And we're building the largest refueling station for hydrogen in Prince George. And then from there, moving into Edmonton with our partners at the Edmonton International Airport. So that's all along Highway 16. So we see this heavy duty corridor that we're trying to encourage along that highway. And then if we take that west, we actually get to the port of Prince Rupert, which is Canada's third largest port, and with LNG Canada, soon to be Canada's largest port. So I think it's important to, start thinking small. As Jay mentioned, we're slow but increasing investment in the national EV charging network. Same thing, I think, with hydrogen and being really strategic. Connecting, for example, Edmonton, this industrial heartland, over to what will be Canada's largest port. So building out those corridors, but can connect over time, is, I think, really helpful for getting the industry going and recognizing that, we can't do it alone. Hydra doesn't plan on building every single hydrogen heavy duty station in Canada. We certainly hope to work with partners like HTEC and others on getting as many stations as we can online and being able to access one another's networks.
Thanks very much. Jeff, Todd, a national accounts manager for an automotive firm, asks, is there a possibility in the future to have a hydrogen fill station at your place of residence? I mean, obviously, that's one of the big advantages of BEVs. Is that a non-starter? Is it too expensive, too large? Or do we ever see home electrolyzers, Jeff?
Yeah, there's been some talk about home electrolyzers and home steam methane reformers converting natural gas to hydrogen, and that was bandied about, I'd say probably a decade ago. I think with the current filling technology and the time to fill, I think how we're going to see at least the light duty market is we're going to see it growing at sort of existing or even some greenfield fueling stations that'll be centralized rather than at your home. There's a fair amount of costs that go into some of the equipment that goes into hydrogen production, and just to do that economically in your garage, when you can fill, like I drive a Mirai, I fill in 5 minutes, and then I drive, whatever the range happens to be, 500 kilometers or so. So it's technically feasible, but it's a big economic challenge. And if you have a neighborhood fueling station that's convenient and fast and relatively cost effective, I'm not sure you need it.
Thank you very much. Randy, the president of a consulting firm dealing with low carbon energy, I guess an expert in the very field we're supposed to be discussing, basically asks, is hydrogen a better ZEV option for rural transportation, light and heavy duty, as compared to battery electric by comparison? Craig, why don't you have a go at this one?
Sure, thanks. Well, at the risk of sounding biased, being the hydrogen guy, sure, I'll say yes, absolutely. But in reality, I think the answer is it very much depends on, the use case and the duty cycle, right? So I think it's fair to say that hydrogen is a little bit more versatile fuel as an option. It does work really well across the spectrum, from light duty, even things like forklifts, all the way up to 40-ton heavy duty trucks. And so absolutely makes sense in a lot of cases where batteries may not be as good of a fit. So in rural areas where you may not have access to charging at a regular basis, I would say that hydrogen could be a really good opportunity. Conversely, someone might say that, look, if I'm in a rural area and I don't drive that much, then I don't have to recharge all the time. So maybe maybe battery electric is fine. I'll say that it really, whatever the transition is going to be, or whatever combination it's going to be it batteries or hydrogen, building out a new infrastructure is going to be necessary, right? And that's something that we shouldn't lose sight of. We don't just plug in a truck with a megawatt of batteries on it and charge it over, in a couple hours. That's just not how how physics works, right? So we are going to, as a world, as a country, as a society, have to grapple with and address these challenges.
Thanks very much. Got a couple of last minute questions, and one of them is pretty general. It asks, what is the one thing that is required for the hydrogen economy to take off, or at least sustain this latest momentum? Dr. Mahmood, I'll start with you. I mean, from your perspective of creating a new technology, what's the most important thing you need to move forward?
I think cost-effective production, that's what we need. So we need to develop the technologies which can make the hydrogen affordable by a common man, especially those who has a less income, but they want to contribute towards the zero emissions or a net zero society.
Perfect. Thank you very much. Jeff?
I think, staying the course. If you look at jurisdictions, like we've had a couple of waves. I think, David, you and I talked about that before, in the hydrogen sector. And if you look at the jurisdiction like California that has, stayed the course between the sort of the hydrogen waves, they're really at a big advantage because there's infrastructure, there's experience, there's a talent base here on the engineering side. So, I would say, if just having a plan and following through on that plan, and, through changes in government and different opinions and things like that, if you can keep that consistency and keep aiming at a net zero 2050, then, to me, that's the most important thing.
Jessica, over to you. What does Hydra need more than anything else to continue converting these trucks to from diesel to hydrogen? I mean, we are in an electric revolution, and everybody understands that electric vehicles will move forward, but nobody talks about existing cars. You're doing a great service. You're taking existing vehicles and turning them into green vehicles. So what is it you need most of all?
Sure. I think for this to work, I'm going to echo Nasir that we need low-cost hydrogen. And what it really comes down to is being able to attract customers. So, we can have all these ambitions like Jeff was pointing out, but if we don't actually have cost-effective solutions that people are willing to adopt, they don't have the same performance or what have you, this just isn't going to get off the ground. So we need to work, as Dr. Nasir said, on having these low-cost production methods, just bringing the cost of the whole package down to a reasonable level that's competitive with the incumbent technologies, which is diesel today.
Thank you. Well, wait, I got time. I'm seeing on my clock for one more question, and I left really to the last because I didn't want to be accused of being egotistical. Bill, an electrician, so he should know something about this, I guess, asks, and I do quote, David Booth made a great point promoting hybrid electric hydrogen powered vehicles. So hybrids made of both electric and hydrogen rather than electric and gasoline. If range is such a problem for BEV pickups, why not have a hydrogen electric pickup? Well, who better than Toyota to lead that charge? Craig, what do you think of his suggestion, Bill's suggestion?
I love the idea of a hydrogen or fuel cell pickup. It's certainly in the U.S. At least, the light duty truck segment is the place where all the action is and where where most customers are buying vehicles. So, the Mirai, or I imagine any kind of fuel cell pickup truck is already a hybrid, right? So it is a combination of battery and hydrogen to power the vehicle. So not just only hydrogen, right? That's a really key thing to mention. As for future product sort of things, well, we'll just have to wait and see what's coming.
I'll put you on the point a little, just one more time.
Sure.
Don't pickups make more sense than say smaller sedans for conversion to hydrogen? Because they're larger, there's under frame area, you have place for even greater hydrogen storage facility, like more tanks, and you can get even greater range, and that really supplants the problems that current electric pickups are having, which is poor range, especially poor range when they're towing.
Yeah, no, it's a good point. Of course, I think that having a larger chassis to deal with helps for packaging. Certainly, that said, Mirai is a mid-size sedan that gets 400 miles. So we figured out how to do the packaging correctly for that. That allows for coverage of, I think, most people's expectations as it relates to being able to drive a certain amount of distances. Yes, of course, in the case of trucks, we could maybe potentially package more tanks and provide longer range. I think the opportunity for towing, as well as not just range, is great for hydrogen in the light duty truck segment.
Thank you very much. I mean, thanks very much, all of you. Well, folks, unfortunately, that's all the time we have for today. Reducing carbon dioxide in our atmosphere is the challenge of our times. Enough of a challenge that eliminating greenhouse gases from the transportation sector needs all the solutions it can get. Hopefully, hydrogen will be one of those. Certainly, Craig, Jeff, Jeff, Jessica, and Nasir made an excellent case for its emission-reducing credentials. I sincerely thank you all. Thanks also goes to everyone who joined us for this discussion. Hopefully we edified and entertained. Again, my thanks for watching, and please join us for future Driving into the Future panels.